So we're going to start off with the chapter 6 multiple choice. And number one's pretty easy. We just need to make sure that whenever we have 1 over x squared or x cubed or anything like that, we rewrite this in polynomial form. So then we add 1 and divide, right, to our exponent. So -2 plus 1 is -1, and then we divide by -1. A lot of students get confused and they try to make this one ln of x. Remember, the only time you're going to get ln of x is if it's just 1 over x to the first power. That's ln of x plus c. But 1 over x to any other power, we're going to need to do this rewriting it as a polynomial. All right, the next one, we are given the graph of g of x equals the integral from -2 to f of t dt, and we're asked which of these is the greatest. So -2 is our starting point. I kind of drew a straight line there. And then on A, we're going to do the integral from -2 to -3. So that's this area. Now, because we're going backwards, that's going to be a negative area, right? So it's whatever the value of g of -2 is plus a negative area. For g of -2, that's going to be 0, right? Like the integral from -2 to -2 of f of t dt, right? That would be 0 because our endpoints are the same. For c, we're going to get the integral from -2 to 0. So now we're going to have this area here. So that is going to be a positive area. But d is even bigger. D is that area plus this area. It's that entire thing. So that's even bigger. So I kind of drew 2 positives just to kind of help me out. And then e goes all the way to +2. So it's that positive area, but then we subtract this negative area. So it's going to be a little bit smaller. So our greatest value here would have been g of 1. All right, next up, we have a graph of this function. They say which of these has the least value. They give us the integral, a left, a right, a midpoint, and a trapezoidal sum. So the integral is just the exact area under the curve, right? That's like the exact area under the entire curve. And when they ask, for which ones are over or under estimates, we do need to know how to do that. But if they ask which one has the least or the greatest value, that's always going to be the left Riemann sum or the right Riemann sum, always. So you could immediately kind of get yourself to a 50-50 shot if you remember that. And I just kind of showed how to graph these. So for LRAM, I start on my very top. I know it says with 4 subintervals, don't worry about it. You can basically do this with just doing the endpoints. So I started off on the left endpoint, and I went above, from the left endpoint, I just drew a rectangle. That's above our graph, so it's an overestimate. For our right Riemann sum, I start on the right endpoint, and I drew a rectangle from the right side. That's below our graph. For trapezoid, I connected our 2 endpoints, and then you bring them down, and that makes, in this case, it's a trapezoid, right? But it's a triangle plus that little rectangle, but still that's underneath the curve. And then for the midpoint, you go in the middle of, this is from 0 to 3. So the middle's at 1.5. And you just go to the right side and to the left side. Now it's hard to tell if this one's over or underestimate, but it looks like this area here is like extra, and this area here is like underneath. It's not enough. It looks like the little underneath area is smaller, so it looks like this is an overestimate. But again, we don't really need to know that. They just asked us which one was the least value. So the smallest one here is the RRAM. Okay, next up we have a properties question. On these questions, I always go to like what it's asking me for, and I write that first. So I just write out the integral from -5 to 5 of f of x dx. And then what I look for is I want to be having an integral that starts off with -5 on the bottom. So do I have an integral with -5 on the bottom? I do. So I'm going to do that one from -5 to 2. Now I need to start with an integral with 2 on the bottom because now we're at 2. So my other integral, does it have 2 on the bottom? It doesn't, but I can always flip my endpoints. So if I flip my endpoints, then instead of being at -4, this value is going to flip to +4, right? So we got -17 essentially plus 4, which is -13. All right, next up we have a question where it says if g of x is an antiderivative for f of x and g of 2 equals -7. Anytime they kind of give us one endpoint and they're asking us to solve for another endpoint on an integral question, we always do FTC. Now, you can do the integral essentially of, it would be the integral of f of x dx from 2 to 4. And then you can say that this would equal g of 4 minus g of 2. That's like the original FTC, right? Where 4 comes first, 2 comes second. I really like to, though, rewrite FTC where I put what I want on the left side, and that goes with our top endpoint, and then the other one, the starting endpoint, on the bottom. And so I rewrite it this way. So this is negative 7 plus the integral from 2 to 4 of f of x. We don't know what f of x is, but we can just write it that way. They use t's, that's okay. It's the same concept. All right. Next up, what is the average value? So when we see the word average value, we're going to do the average value formula. This is a calculator question. You literally just type this into your calculator, get the right answer. All right, next one is a non-calculator. The integral of sine is negative cosine. And then we're evaluating from 0 to pi over 4. So cosine of pi over 4 is square root of 2 over 2, but we have the negative. Then minus cosine of 0 is 1, but we have the negative. And so that becomes negative square root of 2 over 2 plus 1. All right, in this case, we're given this formula. We're asked what is the value of the integral from negative 3 to 3 of f of x plus 1. And then we are told that the area of each of those sections, A, B, and C, are each equal to 2. So when we do this, anytime you have something like this, like the integral from negative 3 to 3 of f of x plus 1 dx, right, like plus a number or plus something, you want to always split this. Okay, you always want to split it into two integrals. So that's what we did here, is we split the integral from negative 3 to 3 of f of x and the integral from negative 3 to 3 of 1. So kind of right here, that's kind of where I'm splitting it, if you see. So the integral of 1 becomes x. Then we plug in 3 and negative 3, and we get 3 minus negative 3. That's a value of 6. Then this integral we're going to do is the area under the curve from negative 3 to 3. That's negative 2 plus 2 is 0, minus 2 is negative 2. So that being negative 2 plus 6 was 4. All right, we have a rate question. And we want to remember here that the integral of the rate gives us the amount of change. Okay, this one's a little bit tricky, though, because they want us to write a formula. And they want us to write this formula for the change in the altitude of the balloon only during the time that its altitude is decreasing. So what altitude decreasing would mean is essentially that the rate of the altitude is negative. Now, be careful, because R of t already is the rate. So we want when the rate is negative, so we don't need to do r prime because r is already the derivative. That's what we always need to be careful about, is the formula that I'm given the original, or is it already the rate? So in this case, it already was the rate. Right? If we're going to go to the change in the altitude, that's going to be the integral of the rate. So it's going to be the integral of r, because r already was the rate. So we can get rid of d and e. Okay. And then what I did is I just set this equal to 0. But instead of doing it, because I know I want the negative sides, instead of doing it and doing a number line and doing it with the solve button, I find it a lot easier to do it with the graph. So I did it with the graph. To get these points, I did menu, analyze graph, zeros. And then I want the negative section. So these become my endpoints because I only wanted the change in altitude when the height was decreasing, which is the negative side. So our answer is A. All right, 85 tells us that we want a graph where the trapezoidal sum over approximates and the right sum under approximates. I literally just graph them all. So, for trapezoid, I go from endpoint to endpoint, and this is over the graph. For right side, I start on the right, and I go over. That was under, so it's A. You can see what I did on these other ones. If you really want to memorize them, you can memorize them, right? For like which ones are over and which ones are under. I find it easier to just always graph them. But basically, for right Riemann sum, increasing is always over, and decreasing is always under. For left Riemann sum, that's backwards. So increasing is always under, and decreasing is always over. I just find that we have so much to memorize in calc already that this isn't worth it to me when it's pretty easy to do it on our own, but I'll kind of leave it up to you, okay? And so trapezoid's concave up, concave down. So whenever we have concave up, that's always going to be over the graph for trapezoid. And whenever we have concave down, that's always going to be under the graph for trapezoid. So if we saw something that said, the right Riemann sum, or the trapezoidal Riemann sum is an over approximate, that means we need it to be concave up. And the right Riemann sum was an under approximate, so we need it to be decreasing. And the only graph that's concave up and decreasing is A. So you could have done it that way. I like to just kind of draw them in. All right, next up we have a particle question, and we're given the particle's position. That's very important, is that we're given position, not velocity. Okay, this is actually, I believe, a repeat question that we did on the last practice test too, but it's just important, so I threw it in here again. And this says, when is the velocity of the particle increasing? So velocity increasing, a lot of students try to pick when the graph is going up because they see the word increasing. Some students also just pick the positive because they see the word increasing. But you need to make sure you're connecting it to the right graph, right? Kind of remembering that basically position goes with f of x, velocity goes with like f prime of x, and acceleration goes with f double prime of x. So if we're asked when is the velocity increasing, that's kind of like saying when is f prime increasing, not when is f prime positive, when is f prime increasing. And that matches up with, if we remember, f being concave up, or it matches up with f double prime being positive, right? All three of these things are kind of the same. So since we're given the graph of f, right, because we're given position, then we need f to be concave up, so that's why it's the section from 0 to 2. Okay, next up, this one I went over with my breakout room, but if you weren't in my breakout room, it's kind of a weird question. It probably won't be asked on your final, but it's basically asking us to look at this formula and realize, hey, this is the formula for average value. So this formula is saying the average value is 1. Which one of these graphs has an average value of 1? And what you can kind of do is just go from 1 and just draw a straight line, and you want to see is more of the graph above or below the line 1. So, if I kind of go to the intersection point here, it happened just right after 2. So it was only, underneath 1 for a little bit of time, and then it was above 1 for a long time, and then right as we got close to 4, it went back underneath 1. So this graph was above 1 most of the time. This one's the opposite. It's, staying below 1, below 1, below 1. It pops up just for a little bit, and then it goes back below 1. So more of this graph, it's below the graph most of the time. Here, this graph is literally half above 1 and half below 1, right? And it intersects right in the middle. So, that's an average value of 1. This graph is always below 1 and always always above 1 in both of D and E. So that's kind of how that one works. I know it's a little bit weird. Okay. 91 is a good one to start, especially if you had gotten the wrong answer, if you had chosen B. A lot of students choose B, and the reason they choose B is they forget about this 11. Okay, so anytime we get a Riemann sum question on multiple choice, you want to look and make sure, did they give me some initial value? If they gave me an initial value, you probably need to add it on, right? Because what a Riemann sum does is it approximates the change, right? Which is the integral, it approximates the change, but it doesn't give us the ending answer. It just tells us how much did the integral change by. So the integral from 0 to 6, this is like the change in velocity from 0 to 6. But it's not going to give us the velocity at 6, it's just going to tell us how much it changed by. So if our velocity started at 0, then it does give us the velocity at 6. But in this case, the velocity started at 11. So we have to add on 11, right? And this is that FTC formula, right? V of 6 equals V of 0 plus the integral from 0 to 6 of A of t. We should have that memorized. So this integral we do with the Riemann sum, but we still need to add V of 0, which was 11, right? It was a left Riemann sum, so the widths are each 2, and we're using 2 times 5, 2 times 2, and 2 times 8. This was a calculator question, so you could have just kind of typed that line into your calculator and gotten a final answer. All right, next up, again, this one's a little bit weird, especially between C and E. Most of the AP questions will not have like two answers that are so similar, and so it'll be a lot more obvious. But the first thing that I did here is I picked out the 0. So I picked out this is 0. Now we have x graphs, right? So v is the same as having x prime, right? So when we see v of t equal to 0, that's the same as basically having x prime being equal to 0. So that means we have a horizontal tangent at 3. So if we look at 3, A does not have a horizontal tangent at 3, so we can get rid of it. B does not have a horizontal tangent at 3, we can get rid of it. D does not have a horizontal at 3, we can get rid of it. But both C and E do have horizontal tangents at 3. This graph, when it got reprinted, somehow the graph got a little messed up. It should have been directly over 3. Don't worry that it looks like it's a little bit to the right on these. This should have been directly over 3. So then from there, what I looked at is, okay, well, if velocity is negative, that means we're decreasing, then increasing, then increasing, then decreasing. But both graphs did that. They both decreased, then they increased, and then they decreased. Both of them did that. So now we have to kind of pick between them. So what I did is I just chose one of the points. I ended up choosing at time 1 because I thought that was easy. For basically to realize, okay, v at time 1 has to equal 2. What would that mean on my graph of x? That would mean x prime of 1 is 2, which is the slope. So that means the slope at 1 has to be up 2 over 1, up 2 over 1. So if we look at C, at this point, it does look like it's kind of going up 2 over 1. Like if I draw the tangent line there, it looks like it's up 2 over 1, or close to that. Whereas on E, if I draw this tangent line, it's going like, more looks like it's maybe like 1/2, right? Like up 1 over 2. It looks like it's a lot smaller of a value. So that's why the answer was C. You're usually not going to get something that nitpicky where you have to really look at that. For the most part, what I would expect on an AP exam is that they just hadn't given us that option, right? Where we can just kind of pick out, okay, all of these have zeros. Maybe one of them has a horizontal tangent line here, but it was like flipped. It was like it increased first and then decreased, right? Like it was backwards. So next one we have an object and we're given the x of t, and then it says if the initial position x of 0 is 2 and the velocity is given by this cube root of 1 plus t squared, what is the position? So we need to use our FTC formula for this. Position at 3 equals position at 0 plus the integral from 0 to 3. We need to just kind of memorize this pattern. Right? This happens a lot. This happens with the x of b equals x of a. It happens with the velocities, and then it also happens with like the rate questions, right? Like the amount at b is equal to the amount at a plus the integral from a to b of the rate in minus the integral from a to b of the rate out. And it can even just happen with literally like f and f prime, right? We could get like f of b equals f of a plus the integral from a to b of f prime of x. So all of those are FTC, and we just need to kind of have that pattern memorized. So in the way we know we're doing the pattern is they ask for position, and we're given velocity. And so if you kind of think about that ladder, how do I go from velocity, which is what we're starting at, to position? Well, we take the integral. Now, if I'm given 2 times 0 and 3, which I am, then I do this formula. If I was only given 1 time, that's where we have to do like the integral and the plus c business. So I'm given 2 times, so we're going to do this formula. One thing to note, I put a screenshot here, is to get this cube root on your calculator, it's control, and then to the left of the square root is this n squared root of x. And on your calculator, it'll just kind of pop up with like a box square root of x for you to enter in what root it is. So like that would give you a cube root, a 4th root, a 5th root, a 6th root. It's that button right there. Okay, next up, we're asked for the average velocity from time 0 to 3. There are 2 formulas for average velocity, right? And we do it based on what we're given. In this case, we were given a formula for velocity, so we're going to do that formula. So you just type it into your calculator, get an answer, nice and easy. Next one, a particle moves along an axis. We're given a formula for a of t. And then we want to know the velocity of the particle at time 2. This is very similar to this question 87, but with velocity and acceleration. right? So v of 2 equals v of 1 plus integral from 1 to 2, that FTC interpretation. We just type it into our calculator, we get choice E. All right, next one, we are given a formula where we see barrels per hour, and they ask the total number of barrels. So if we're going to chop off per hour, we know that's an integral. Or we could have also kind of seen, that we're basically going from the flow of oils, again, in barrels per hour, and we want to know the total number of barrels. So again, we're chopping off, that's doing an integral. So we want to know the integral from 0 to 24. And they say to approximate it, so that's the area under the curve. What I did is I just broke each of these up into basically squares, right? 6 times 100, so each square is 600. And these were triangles, and they were basically splitting the squares in half, so I made them each 300. So you add all that up, and we got 3,000. Okay, next up, this is the one where technically, even though it kind of looks like we're given 2 endpoints, we're only given 1 endpoint on these. We're starting off at A of t, and they give us that the velocity at time 3 is 25. So they give us v of 3 is 25. And then they give us that the position at 1 is 10. Now technically that is 2 times, but 1 is for position and 1 is for velocity. So really we only have 1 endpoint for each. So the way that we do this is I write out a of t equals 6t minus 2. Then I do the integral of both sides. I wrote this in a second line just so you can see it. The integral of a of t becomes v of t. In this integral, we just do 6t squared over 2 minus 2t. We need to add the plus c because we're not doing any endpoints here. Then once we get the plus c, this is where we're going to plug in that v of 3 equals 25. So 25 goes where v went, 3 goes where t went. We solve, we get 4 equal to c. And so then we rewrite that line, but using c as 4. Now we do the same process again. We take the integral of both sides. So we did the integral of both sides. Integral of v becomes x. 3t cubed over 3 minus 2t squared over 2 plus 4t plus c. And then we plug in x of 1 equals 10. So we plug in 10 for x, 1 for t, and we get 6 equals to c. And so then now we take this line and we write it with the 6. I wrote it over here, and that's our answer. Okay, this next one basically was just, did you pay attention to the properties, right? Do we know our properties? So, the first one is like a multiplication property. There was no multiplication property. The second one is that addition property, which is a property. And the third one is some square root thing. And the square root was not a property. So, we never learned anything about 1 or 3, but we definitely learned about 2. All right, next one is very, very easy. Usually, if there's a question that's like question 1, even 2, 3, 4, there are a lot of times really, really easy questions. So this one, just 4x cubed over 4 minus 6x squared over 2, and then we just evaluate from 1 to 2. All right, 3, this is that same one that I talked about earlier where I said if you see like f of x plus 5, you want to split that. So we split into the integral from a to b of f of x plus the integral from a to b of 5. And they gave us that this integral was a plus 2b. So really we're doing a plus 2b and then plus 5x from a to b. I know they're not numbers, but just plug in b and plug in a. So we get 5b minus 5a. Then add your like terms. A minus 5a is negative 4a. 2b plus 5b is 7b. They wrote it backwards. That's okay. All right, we did question 8 before, but I repeated it because now I want to talk about question 9. So this is a bug, and we're given velocity. So when does the bug change directions? That's when v of t changes signs. That happens at 6. What is the total distance that the bug travels? So our total distance formula is the integral from 0 to 8 of the absolute value of v of t. So if you ever get a total distance question on the AP exam, most likely it's going to be a calculator question where you can just basically plug in this formula to your calculator. If it's not a calculator question, it's probably going to be a graph question. So we do this the same way where we break it up into like a triangle, a rectangle, a triangle, and a triangle. But because it's absolute value, every single one of them will be positive. For distance, everything's positive. It's impossible to have a negative distance. So that's kind of how that worked. You should get 13. You can go over the answer, but it's nice and simple. Okay, 20 is easy, but there's a hard little trick at the end of it. So it says the average value of cosine of x. So we do 1 over 5 minus negative 3, integral from negative 3 to 5. That gives us 1/8. Integral of cosine is sine. We plug in 5 and 3, 1/8 times sine of 5 minus sine of negative 3. It's a non-calculator question, so you can't type this into your calculator. We're just going to write sine of 5 minus sine of negative 3 because we don't know what they are, and that's what the answers look like. So we can bring this to the top, right? But what happens, and this is what's weird, is that, and I might even do it like right here. If we kind of looked at this to the top, we would end up with sine of 5 minus sine of negative 3 over 8. And then that's the answer we're looking for. And when we look at the answers, okay, we can get rid of B, C, and D because they all have a 2. So at least if you're going to guess between A and E. But, there isn't, they both have positive 3 here, and that's kind of confusing. So this is a topic that we should have learned last year in Math 3, but with distance learning, it got skipped. And so it's just something where, take your best guess or learn it now. So I did go over this in the review unit, but I know it was really, really brief, and so I'm sure not all of us remember this. But there is a concept where basically whenever we have the sine of negative x, you can pull that negative out and it becomes negative sine of x. Whenever you have the cosine of negative x, actually the negative just goes away and it becomes cosine of x. The reason for this has to do with how we do our unit circle. On the unit circle, we don't have like x comma y values, right? We have actually, it's called parametric. It's something you might learn if you take Calc 3, a little bit Calc 2 as well, where we have theta values, right? The theta is the angle that we go over, right? So we're going over by an angle, and then we actually also have r values, which is like how far out it goes, but don't worry about that. So the x's though, like when we do sine of negative x and sine of x, the x's are this angle that we take. And so this would be going out a positive x direction, whereas going down would be going out a negative x direction. And if we remember, all students take calculus. Well, if we look at it, if we go out a positive direction, we're in the all, where everything is positive. If we go in the negative direction, we're in C, where only cosine is positive. Sine would be negative here. So that's why this happens, right? Is when we go in the negative direction, sine becomes negative. Whereas for cosine, when we go in the negative direction, we stayed positive. So that's kind of why this is true. Okay, now you don't necessarily need to know why that's true. It's just something that you could memorize if you want to, or if not, don't memorize it. It probably won't happen on the AP test. I've seen it like every once in a while. But anyways, now that we've kind of learned that, basically what we did is we just took that negative sign, pulled it out, and so it became sine of 5 plus sine of 3. So choice E. All right, this next one's kind of an interesting take on FTC. And we have the integral from 1 to 3 of f of x is 2.3. So from 1 to 3, that's this shaded area, right? That's from 1 to 3 is that shaded area. I think I went a little too far with the blues. So that's that shaded area. And then they say, what would be big F of 3 minus big F of 0? So we need to kind of realize, okay, the integral from 0 to 3 of f prime would be big F of 3 minus big F of 0. Well, f prime is f of x, so that's just going to be our area under the curve, but it's from 0 to 3. Well, that's this rectangle plus our shaded region. So the rectangle is an area of base times height, 2 times 1. And then we're going to add on the 2.3, so we get 4.3. All right, next we have another particle motion question. So we're given acceleration, and we're asked for what value will the velocity be 0. So velocity 0, just set v to 0. So to get from A to velocity, we need to take the integral, right? Position, velocity, acceleration. So we're at acceleration. We want to get back to velocity. We take the integral. And we're only given one endpoint. We're given at time 0, the velocity is -2. So one endpoint is where we do this integral with the plus c. So we take the integral of both sides, right? This was a calculator question, so you could just take the integral with your calculator, but make sure your calculator will not add c onto it. Or you could have done this by hand. I did it by hand, t squared over 2, and then integral of sine is negative cosine. But you could have typed that in your calculator to make sure. Just remember to add the plus c. Then we plug in -2 for v, 0 for t, and we get -1 is c. So this gives us v of t equals t squared over 2 minus cosine of t minus 1. Set that equal to 0. I use the solve button. You also could use the graph, and we get 1.478. Right, next we're doing a trapezoidal sum. This is pretty easy. Just make sure you know it. Right, we do our widths. Each of these widths is 0.5, and we add both endpoints and divide by 2. So the first width, 0.5, add our endpoints, divide by 2. The second one would be 3 and 5. Right, 0.5 is the width, add both endpoints, divide by 2. The next one is 5 and 8, add both the endpoints, divide by 2. Okay. Next up, we have the graph of a linear function. And we're asked for the value from -1 to 4 of f of x. And so we're just doing the area under the curve. Okay, nice and easy. We're starting off at -1, so everything's going to be normal. This is positive, positive, positive. Below the axis, negative and negative. Just add up the areas of the squares and the triangles. Okay, number 3 is actually almost identical to the very first question that we did today, but adding on endpoints. So, add 1, divide x to the negative first over -1. I just rewrote this. I pulled the negative out, and I moved that to the denominator. So we get -1 over x from 1 to 2. It's -1/2 minus -1 is +1/2. 5 is kind of weird because you have an x in it, but just do the same steps you normally would if there was a number, like 0 to pi. So the integral of sine gives us negative cosine. Then just plug in x and plug in 0. So we get negative cosine of x minus negative cosine of 0. Negative cosine of 0 is -1, right? Because cosine of 0 is 1 and the negative sign. And the negative turns positive. All right, this one's pretty weird. This topic we did see a little bit on one of the FRQ questions from the last video. And that's basically that, having f double prime and having linear. Okay, to me, the easier way to think about this is what I did up here. So whenever we see linear, we know f double prime of x has to be 0, right? We talked about that last video. Concave up is f double prime of x is positive. Concave down is f double prime of x is negative. And linear would be concave f double prime is equal to 0, right? That would be what a linear function would have. So in this case, if we just kind of thought about it that way, what we could have done is with our integral from a to b, we could have just changed f double prime to be 0 because it was a linear function. And the integral of 0 is just 0. The other way I guess we could have thought about it is the integral of f double prime will be f prime. So we get f prime of b minus f prime of a. These are the slopes, like the slope at b minus the slope at a. And for a linear line, right, we have constant slope. So it doesn't matter, the slope is always the same, right? So they're equal. So something that's equal to each other when we subtract will be 0. Okay, whenever you see these ordering questions, it's always going to be negative is less than 0 is less than positive. So just kind of think which one is negative, which one is 0, which one is positive. We're given a graph. So on this graph, right, f of 1 is 0 because it's on the x-axis. F prime of 1 is the slope. This graph looks like it's increasing. So f prime of 1 is positive because the slope is increasing. Then f double prime of 1 is less than 0 because this is concave down. Okay. Sorry, I said slope is increasing. The slope is not increasing. The slope is positive, which means that basically f is increasing. Okay. What are all the values of k for which -3 to k is x squared? Again, same thing that I said before is just with the x1, just do the integral and just plug in k as if you would plug in a number. So we have x cubed over 3, right? Plug in k cubed over 3 minus -3 cubed is -27 over 3. We get k cubed over 3 plus 9. Now, they said, when is that equal to 0? So we're going to take k cubed over 3 plus 9 and set it equal to 0. I multiplied each term by 3. That gave me k cubed plus 27 equals 0. Subtracted 27, took the cube root, we get -3. All right, next up, we have a trapezoidal approximation. And for this question, we're just doing the same thing we did earlier. Width, right, is 3, and then 10 plus 30 divide by 2. Width is 2, 30 plus 40 divide by 2. Width is 1, 40 plus 20 divide by 2. This was a calculator question, so if you had wanted to, you could have even plugged the, this into your calculator and gotten that answer. Okay, next one, we have a point that is moving on a straight line, and its distance from a fixed point. When you see distance from a point, that's actually position. That's not total distance. That's the definition of position. Position is your distance from the origin. Okay? And then they say, what is the total distance from 1 to 2? So what we need to do here is, it's a little bit tricky, but our distance formula, right, like our total distance formula, is that the total distance is the integral from a to b of the absolute value of v of t dt. So what we need to do is we need to take this 8t minus 3t squared, and we need to take the derivative to get to v of t. So that gives us 8 minus 6t. Then we're going to take the integral from 1 to 2 of the absolute value of that, and we get 5/3. All right, next up, if f prime of x equals 2 over x, and then f of squared of e equals 5, what is f of e? So anytime, just like how we had like position, velocity, and acceleration, right? Whenever we wanted to go up the ladder, we do an integral. You kind of think of the same thing with f of x, f prime of x, and f double prime of x, right? Anytime we go down the ladder, we're taking a derivative. Anytime we go up the ladder, we're taking an integral. So we're at f prime of x. We want to go up to f of x, so we would need to do the integral. So this is FTC. You could write it, either this way or the other way I've been showing you guys. I wrote it this way just to have my bottom endpoint on the bottom, but either way is fine. I think we could have written it the other way as well. Right, f of e equals f of square root of e plus integral from square root of e to e of f prime of x. That would have worked also, right? We could have written it that way. So anyways, the integral of f prime is 2 over x. That's 2 ln of x. And then f of e, we don't know. F of square root of e was given as 5. So 2 ln of x, when we plug in e and square root of e, this is a little bit tricky, right? When we plug in e, that's nice and easy. Because the ln of e, they just cancel out to 1. So 2 times 1 is 1. For the ln, like 2 ln of square root of e, you cannot cancel out the ln and the e because the square root's blocking it. So what we need to do is we need to rewrite the square root as 1/2 power. Now we can cancel them out, and we get 2 times 1/2 is 1. So 2 minus 1 is 1. Add the 5 over, we get 6. Okay, next one is very easy as long as you make sure that you remember that that first step in taking an integral is to rewrite it in polynomial form. So we just had to do either box method or FOIL, right? I did FOIL. And so I did FOIL, and I got x to the 6th plus 2x cubed plus 1. And then we just take the integral, and nice and easy. Right, the 7 we just moved to 1/7. 2 over 4 is a half. We moved it to a half. All right, next up. Again, this is just kind of doing this FTC over and over again. It's going to happen a lot on our test. So instead of f of x, right, we can write this as g prime of x. So the integral from 1 to 3 of g prime of x is g of 3 minus g of 1. If you had wanted to kind of show more steps, you can kind of do it this way. Is the integral of g prime would be g of x from 1 to 3. And then we plug that in, and we get g of 3 minus g of 1. But if you want to directly just apply FTC and just jump straight to there, that works. That's what I did. Right, so to get g of 3 and g of 1, I just plugged them into our formula. Right, so g of 3 we plugged in, I got 4. G of 1 I plugged in, I got 2. 4 minus 2 is 2. Okay, next up we have a graph, and we have 3 areas, right, 20, 6, and 4. And we're asked for the absolute maximum. And it doesn't say absolute maximum, but I know it's absolute maximum because whenever they say the maximum and they give me an interval, that's absolute maximum. So they gave us f of 0 was 2, and we need to kind of know this formula is basically that any f of t, like any f of t, any value, will then be f of 0 plus the integral from 0 to t of f prime of x dx. Right, and instead of f of 0, we can replace f of 0 with 2. So that's the formula we're going to be doing. So we're starting off at 0. Right, to get f of a, we do f of 0, right, the 2 plus the integral from 0 to 9. Well, the integral from 0 to a. Right, I just called this value a and this value b. Right, and the reason I did that is because the first step in doing the absolute max, which I kind of skipped, is you always want to set f prime of x equal to 0. Make sure you write this down, like especially on the FRQs, you write this down. Even if you don't do the table, this is always 1 to 2 points. So you can get 1 to 2 points even without doing the table. Right, so my zeros, I just called them A and B. You could have called them whatever you wanted. But basically, we need to check, the endpoints, and then these two critical points. So basically at 0, we have a value of 2. At A, and you don't even have to write all this out, right? If you just kind of did it in your head, well, I know it's 2, and then we added on 20. So we're at 22. And then you'd say, now I'm at 22, and I subtracted by 6, I'm at 16. Now I'm at 16, I added by 4, I'm at 20, right? So the biggest value there is 22. All right, next we're given a velocity, and we're asked what is the acceleration at time 6. This is review from last chapter, nice and easy. Just take the derivative and plug it in, right? So position, velocity, acceleration. We're at velocity, and we're going down to acceleration. We take the derivative. All right, now we have another one of these properties questions. And like I said before, if we ever have this adding, just split it up. So integral of 3 plus the integral of 2f of x, and I just brought the 2 outside. Integral of 3 is 3x, plug in 5, 15 minus 0, so this side is 15. For this side, the integral from 0 to 5, I just did it off on the side. The integral from 0 to 5 would be, I want to find something that starts at 0, so 0 to 3. Now I'm at 3, I want to start something that starts at 3, 3 to 5. Okay, and so they gave us both of those. 0 to 3 was 6, 3 to 5 was 4, so this is 10. So 2 times 10 is 20, 20 plus 15 is 35. Okay, next up is just kind of one of these reading and making sure we interpret the correct value. So H is representing the temperature in Celsius, and we want to know H prime of 24. So if I'm given units, I know that when I take the derivative, it's going to be degrees per hour. But none of these have units, so that didn't really help me. But I just need to kind of remember that basically the derivative goes with the rate, and the integral goes with kind of the change in the amount. So since I'm starting off at temperature, if I'm doing a derivative, h prime, then I want something that has a rate in it. So A I can cross out because it says change. B I can cross out because it says change. C I crossed out because of the word average, right? H prime is not an average formula. H prime is just the derivative at a point. And so that's why E is correct and not D. D says during the first day. The first day would be from 0 to 24. E says the end of the 24th hour, that would be H prime of 24, right? That's like a single point. Right, 79, we're given a spherical tank that has 81 gallons of water at time 0. For the next 6 minutes, water flows out at this rate. How many gallons? So how do we go from a rate back to an amount? Is we take an integral. Right, the integral of the rate gives us the amount, or really the change in the amount. So our formula that we're doing is basically that A at B equals A at A plus the integral of the rate in minus the integral of the rate out. I wrote the rate in minus the rate out because this is a rate out. So it's going to be negative. A lot of students mess this one up and they added on the integral. We need to subtract the integral because it's a rate out. So it's 81 minus the integral and we get 36. Okay, we have another total distance formula. Super easy question if you know the formula. Just integral of the absolute value of v of t. They did make a little bit of a tricky thing here though, is they said that at time 0 the particle is at position 1. Okay, so a lot of students get this question wrong because they choose E, because they added on the 1. They see the 1 and they're like, oh, we have to add it. Okay, if it had said what is the position at 1, well, the position at 1, the position at 4, right? The position at 4. If that's what they had asked for, that would be the 1 plus the integral from 0 to 4 of v of t without absolute value, right? We would add the 1 because we want to know where does it end at. But when they say total distance, we don't care where you started, right? You could have started at the 0, you could have started at 10, you could have started at 20. If I want total distance, I just want to know how many steps you took from that spot, right? So if I just want total distance, we never ever add on that initial point. Okay, next up, we have another rate question. And then they ask, what is the average rate, right? So average rate, and I already have a formula for the rate. So I'm going to do 1 over b minus a because those match up. They're the same thing. If it had said average rate, But instead, I'd been given, another formula. We may have done the f of b minus f of a. But because these match up, right, average rate, and we have the formula for the rate, they're the same thing. Even though it says average rate, this is where it gets really tricky. This is actually an average value question, right? And it's because basically we have the formula of the rate. So whenever those are the same thing, we do that. Now, if it had said average rate and we were given, the value for the amount of, basically the amount of vegetables or the amount of water, whatever it is, the amount of water sprayed, right? If we were given some amount formula, then we would have done like a of b minus a of a over b minus a, because we saw average rate and we had the amount. But whenever like it matches up, that's always average value. So this was actually a really tricky question. Okay, here's another one of these over-under approximation deals. And so, like I said, I just, you can memorize increasing, decreasing, and concavity. I just draw them in. So for my left Riemann sum, I start on the left and go over. The right Riemann sum, I start on the right and I go over. And the trapezoid, I connect the dots. And so in this case, it says which of these are underestimates. The trapezoid on the left were under the curve. Okay, we have another maximum value on 0 to 2. That's absolute max. We want to always start off setting the derivative to 0. So on my calculator, I did that. You could have done it with the graph as well, right? Those are my two zeros. I could have used like menu, analyze graph, and done it that way. And so I get 0, 1.46, and 1.8. Now this one's tricky because we don't actually have a way to find these values, right? The formula to get back to like, if I was trying to solve for f of 1.46 would have been equal to f of 0 plus the integral from 0 to 1.416 of f prime of x dx, right? And we don't have a way to do that because we don't know what f of 0 is. But here's the deal, is I kind of cheated and I did, the f prime, like my number line analysis. And so I graphed this to see the number line analysis. And I see that we're increasing because it's above the axis. This is f prime. Above the axis is increasing, decreasing, and increasing. So what I know is the only possible maxes are either 1.46 or 2. So I got rid of 0, I got rid of 1.8. And so, this guy here, what we can kind of look at is at 1.146, it would be whatever f of 0 is plus that area, right? And then for f of 2, to figure out if it's bigger or smaller, well, now we're going to subtract this area and add on this little area. And this to me looks bigger. So it looks like we decreased more than we increased. Okay, so that's kind of how I did that. You could have also actually on your calculator, you can in like menu, analyze graph, there's an integral option. Or you can just do the integral by hand, like you could have done the integral from 0 to 1.416. So the integral from 0 to 1.146, that area was 0.59. And the integral from 0 to 2 was 0.45. So this we added on more, that kind of confirms it. But this was a tricky question for sure. Okay, and then now that's it for our multiple choices. Hope this helps, and I will do the free response in the follow-up video.